painful process, I know. So I'm talking about yesterday, the last problem, number 7. This is your hint, okay? If you were to do 11x minus 12 is equal to 9 times x plus 2 and solve for x, okay? Once you solve for x, then you go back and substitute in here for x, okay? So your first angle is 11x minus 12. So if you sub in what your results are for x in here, you will find what the first angle equals. If you substitute in for x on the second angle, which was 9 times x plus 2, you substitute your value for x in here, and you solve this expression. You just are getting a number. When you're subbing, you're just getting a number, all right? Then you will find what the second angle is, okay? With that meaning, all right, and I'm going to give you another hint because it doesn't ask you. It only asks you for those angles, but what you're going to need to be able to do eventually is, guess what? How many degrees is this? A half a circle. 180. So if you knew what this angle is, you would be able to, let's say we named this angle 3, okay? You would be able to figure out what that angle is, wouldn't you? Because you could take 180 and subtract that. And it wasn't part of this, but I'm just showing you the next level, okay? Then if you knew what this angle is, you could draw a half a circle. And we're going to get into these, by the way, but we're going to do them. They won't quite be as complicated as this, but if you did that, then you could figure out what, let's say if we named it angle 4, you could figure out what angle 4 is. Does that make any sense to you? Okay, because we know half a circle is 180 degrees. And when we do our angles, in 8th grade, that's going to be very important to know that half a circle is 180 degrees, because we are going to do vertical angles, we're going to do corresponding angles, we're going to be doing all kinds of angles that you've never heard of before that are going to drive you nuts. But if you have this basic knowledge of a half a circle is 180 degrees, then they're not as complicated, because you just subtract whatever the other angle is from 180 and you have your answer for the missing angle, in other words, okay? So that's just, that's a step further. It didn't ask for that. It just asked you to solve for these angles, but I just kind of wanted to show you that real quick. All right, so I'm only holding you accountable to look at this and this, and you should be able to do this, especially now that I've given you the equation for how to find them, okay? Before yesterday, I know we were cut short a little bit, so at this point, I should be able to get the correct numbers for these two angles, okay? But yes, you're going to have to solve this for x, okay? All right, so let's go on to today's lesson, all right? Please put that aside, and we'll go on to today's, all right? I will be in a meeting, but it shouldn't be very long. If you're around for some reason and need some help this afternoon, I will probably be back here by 4. Or my room will be open if you need a place to work. It will be here. Just want to make that statement. Parameter changes on the linear parent function. So we all need a calculator. As I said before, you need two different pencils that are kind of like opposite colors. That would probably be the best. It's just easier to see, not that you have to use two different colored pencils. You can just use your pencil, that's fine. But it's just nice to be able to see it that way. All right, so the parent function of a linear relationship is y equals x, and we need to understand that is the parent function, okay? So if the coefficient is placed in front of the x, it causes the steepness or slope of the graph to be changed. Think about it, because that's your slope. Right now, you have a slope of what? M is what? When you have y equals x, what is your m? Your slope. And what is your slope with y equals x? What's the number that's missing? 1. Because this is like saying y is equal to 1x, right? So your parent function, so obviously this is your parent function when you graph it. All right, and as we change this number, it changes this steepness to either be steeper if the number is greater than 1, or it's going to get less steep as the number is less than 1, and we're going to see that. So it says, investigate and describe the changes of steepness m has on the graph of the linear parent function. So what I'm going to do is come into my calculator, and I'm going to go to y equals, and I'm going to put in y equals x. All right, that's my parent function. All right, and I'm going to graph it. So I'm going to make all my parent functions, I know, blue, because I knew that it was going to be blue, right? So that is my parent function right here, okay? That's the graph of the line, all right? The value of m in y equals x is 1. Do you see how they've written that? Okay. Up or down from left to right. It's going what? Up, because it's a positive slope. Is the steepness more or less or the same as y equals x? Well, it's the same, obviously. When x increases by 1, y increases or decreases by, it increases by 1, because every time you go up 1, your y value is going up 1. What are the coordinates of the y-intercept? 0, 0. So now we're going to try something else. Here we've got our parent function, and I'm going to graph my parent function on here, and it's always going to be edge to edge, which makes it really easy to graph, and it's going to go right through the origin. So you've got it like this. Okay, here's my parent function. Okay. Now I've got y equals negative x. So what I'm going to go back and do, I'm going to leave my parent function on my calculator, all right? And I'm going to go back to y equals, and under y2, I'm going to plug in negative x, all right? And when I plug in negative x, let's look at the graph now. So I've got my parent still there, and what did we get now? Our graph is just going the opposite way, isn't it? But it is the same. So I'm going to graph my y equals negative x in this color. So always graph your parent in whatever color you're doing. Or you could do this in pencil. It doesn't, you know, it's not going to matter. And mine is off a little bit, okay? It's going to be off a little bit because of the ruler. I slid it over. It should be right here at 0, 0. I realize that. So my value for m in y equals negative x is what? Negative 1. Is it going up or down from left to right? Down. Okay, you can write down. I don't care if you want to give me an arrow that shows me down. That's fine. Is the steepness more, less, or the same as 1? How would you answer that? It is the same. That's correct. It's just going in the opposite direction, isn't it? Because it's negative. When x increases by 1, y, does it increase or decrease? And by how many?
Decrease by 1.
So I'm going to, instead of writing all that out, I'm going to say decreases by 1 because I'm a lazy mathematician. All right? And what are the coordinates of the y-intercept? Well, if I wasn't sure, how can I find the coordinates of the y-intercept using this calculator? What's a tool I have?
Second trace.
No, what about this? Second and table. When x is what? Where is my y-intercept? When x is 0, my y-intercept is whatever my y value is. So I can find when x is 0, my y-intercept is 0. So I know that my coordinate point is 0 and 0. Okay? Remember, we've been telling you on a table for 8th grade, your y-intercept is where x is 0. Okay, so this is, here you go, some more practice on that. So let's go to the next one. So I'm going to try and do this a little better this time. I'm going to put my points on my 3 places, so maybe I won't make such a big boo-hooey and miss my my origin here. It's because the pencil and the ruler, but here we go. Okay, so there's my parent function. Okay, that's my parent. So let's see what happens. Everybody got their parent on there? Okay, so then go back to y equals. Let's go back down to y2. Let's clear what we have for y2, and let's put in 2x. Okay, and then you're going to hit graph. And it's going to come, you know, there's my parent. And there is my y equals 2x. So, what is the value of m in this situation? 2. Okay. Did it go up or down from left to right? It went up. Okay. Is the steepness more or less or the same as y equals x? What do you think? Is it a steeper line or is it the same? It's steeper, isn't it? So it is more steep. Okay. Here they've written it increases by 2. Okay. They're saying that when the x increases by 1, the y value is increasing by 2. That's your rise, correct? All right. So what are the coordinates of the y-intercept? You should be able to tell by the graph, but what are they? 0, 0, aren't they still? Okay, 0, 0. So then I'm going to come over here and I'm going to draw, and I'm going to give myself a couple of points to do this drawing, and I'm going to say, okay, when I go up by 2, I've got to go over, I've got to rise 2 and over 1, rise 2 and over 1. So then I'm going to go down 2 and over 1, and I'm going to go down 2 and over 1, and that's probably enough to get me where I want to get. Now, I could very easily just use my table to make those points, because I could find my coordinate points off that table, couldn't I? Instead of counting rise over run, I could just go straight to my table, second in table, and I could find, let's see, where x is -2, y is -6, which I don't have that. I should have done a better job at my graph here. Where x is at 1, y is at 2. When x is 2, y is at 4. Do you see how I could have plotted my points from here very easily for my second graph? So I didn't make it as steep as it needed to be. It actually needed to be more like, let's see, that actually would have been a better choice. But it's close enough. So with these little graphs, sometimes it gets confusing to count. So there you go. So you are going to go through this paper, and you are just going to be answering the questions. And what they're going to get in is, then they are going to, after that, they're going to ask you some questions and about the graphs on the back here. And they're asking you to make some predictions. How do you know if the graph, if the measure of steepness is positive or negative? That's one of the questions. And then you're going to come over here and you're going to get where they're giving you a different intercept. And so you're going to see what happens there. So this is your job today in class. And you can work on this, and I can be here to help you. This is just to help you understand what that equation does to your graph and how the different parts of it move it, and whether And this is important for you to be able to understand the relations between the two. Okay? Anybody have any questions? No? Okay. Well, I'll be here if you do. Okay? And you've got